Hello student, I'm your teacher Mohammed Khalif. Make sure that you subscribe this channel to get more about chemistry, physics, mathematics, and also biology. Remember that I'm a chemistry that reacts, mathematics that solves, biology that breathes, and physics that power the universe. Work with me as I dive organic chemistry 1 and organic chemistry 2, and I will usually tackle our paper 2 questions. So organic chemistry 1 and organic chemistry 2 usually is one of the most important questions that come in paper 2 chemistry. So and it's a must question. It's a must question. A must question that must come in KCC in every paper 2. So in our channel, we don't do so many theories. We will tackle on 3 things only. Number 1, number 1 is what is tested. What is tested. Number 2 is how is tested. How is tested. How is tested. And number 3 is how is answered. As a student, how do you answer questions? Because that is one of the things that matters a lot when it comes to rules. Remember that this is a science and it has its own rule for marking. So organic chemistry is just a study of compound comprising carbon except carbon 2 oxide, carbon 4 oxide, carbonate, and hydrogen carbonate. Remember that in this chapter we only cover something that's known as hydrocarbons. So it usually covers compound that contain carbon except carbon 2 oxide, because carbon 2 oxide and carbon 4 oxide we covered in carbon and its compound form 2 topic last, which is topic 6, I think. So the property of element where its atom can bond each other is known as catenation. It's known as catenation. It's known as catenation. It's known as catenation. So that's the property of a element where its atom can bond together. So in form 3 we only learn 3 things. In form 3 work we only learn 3 things. Number 1, form 3 we learn ketamine our alkanes. Alkanes with single bond. Scales with single bond. Number 2 is alkenes with double bond. Alkenes with double bond. Also number 3 is alkynes. Alkynes with triple bonding. So as I said previously, I said that I will not navigate deeply on paper 1 or all the topics, but I will concentrate on how question is tested in paper 2. Paper 2, number 1 is tested about naming. Sometimes they may give you just certain structure and they will tell you name it. That's number 1. That's known as naming. Number 2, which is the most important thing, and it can come almost 8 to 9 or 10 marks, is known as flowcharts. And remember that flowcharts contain number 1, preparation and chemical property. Preparation and chemical property. This is the only thing. Flowcharts, all organic flowcharts contain preparation of the different alkanes, alkynes, alkanols, alkanoic acid, and also the chemical properties. This is the most important thing that you have to understand. So let's start with alkanes. Let's start with alkanes. Let's start with alkanes. Alkanes They have single bond. First of all, that's the first thing that you have to know. They have single bond. They have single bond. And I think that it usually will help you in Pp2 is they are saturated. Saturated hydrocarbons. Saturated. They are saturated hydrocarbons. So they have a general formula of CnH2n plus 2. CnH2n plus 2, where n is the number of carbon atoms. Carbon atoms. So that's the alkanes. They are saturated hydrocarbons. Number one, they have single bond. Also, and I think you have to know is they have a general formula of. So number one, first of all, tunajua preparation. Remember that I want to combine organic 1 and organic 2, and this is for Pp2 only. So since this video is for form force, especially form force, now I am expecting everyone knows how to write, how to name also different organic compounds. So I will not concentrate about naming. I will concentrate only two things, that is preparation and chemical properties. So how do we prepare alkanes? How do we prepare alkanes? Preparation of alkanes. How do we prepare alkanes? Alkanes we prepare using sodium alkanoate, sodium alkanoate plus soda lime, which will give you alkane plus sodium carbonate. So sodium alkanoate plus soda lime napatia, alkane plus sodium carbonate. So alkane is the whatever that you want to prepare. Number one, for example, kama unataka prepare methane, itakupatia methane. Ethane, itakupatia ethane. If you want to prepare propane, will give you propane. So sodium carbonate, it will be constant. As long as you prepare alkanes, the product of getting sodium carbonate is similar. All of the alkane, I mean, starting from methane to decane, it will give you sodium carbonate. So let's come to sodium alkanoate, meaning that whatever that you want to prepare. For example, let's get one example. If you want to prepare methane, you will take the succeeding alkane. For example, if I want to prepare methane, I will take sodium ethanoate. If I want to prepare methane, I will take sodium ethanoate. If I want to prepare ethane, I will take sodium propanoate. If I want to prepare propane, I will take sodium butanoate. If I want to prepare, for example, hexane, I will take sodium heptanoate. So ona ile nyuma sa ile inafuata na unachukua. That's the kind of the alkanoate that you're going to take. And soda lime is sodium hydroxide. So let's prepare. So general formula inaandikwa aje? Inaandikwa CnH2n plus 1 kuna. For example, if I want to prepare methane, let's start preparation of methane. preparation of methane, preparation of methane, preparation of methane, preparation of methane. So preparation of methane is tunachukua sodium ethanoate plus soda lime, because nilikwambia whatever that you're going to take is the ile alkane inafuata. For example, kama nataka ni prepare methane nachukua ethane, kama nataka ni prepare ethane nachukua propane, so hivyo unaendelea. So since tulisema it is CnH2n plus 1 kuna, so tunaandika CH2, 2 times 1 is 2 plus 1 is 3, so itakuwa 3 kuna, CH3 kuna plus CH3 kuna plus sodium hydroxide, and patia CH4 which is gas plus sodium carbonate. So I want to emphasize this place. How can I write this place? Because imagine nilisema I will take 2, because earth means 2. So hapa sijasema 2 kwa sababu gani? Because kuna already it takes 1 carbon atom. Kuna already takes 1 carbon atom. Kuna already takes 1 carbon atom. So meaning that kama ulikuwa na carbon 2, kuna imechukua 1, so unabaki na carbon 1. I think you are understanding me. So lakini to count sasa in normal way itakuwa 1 2 1 2, it is 2. Lakini wakati tunaandika CnH2n plus 1, that's a general formula. Hiyo kuna already taken 1 carbon atom. So this is ethanoate, sodium ethanoate plus this is a soda lime. Ile kitu tulikuwa nataka kuprepare sasa ni gani? Ni methane. So this is methane, and also this is sodium carbonate. That's why nilikuwa nakwambia sodium carbonate it is a common for all of them. For example, acha nichukue ni prepare anyone. For example, if I want to prepare propane, I will say propane nini nafuata ni butane. So unachukua sasa first of all sodium butanoate plus sodium hydroxide. Inanipatia sasa nini? Anipatia propane plus sodium carbonate. So ikiwa najua sasa itanipatia hivyo, so nachukuaje? Naandika sasa sodium butanoate inafaa iandikwe aje? General formula ilikuwa aje? CnH2n plus 1 kuna. So but ni ngapi? Ni 4. Lakini 1 carbon atom imechukuliwa na kuna, so unabaki na 3. So itakuwa nini? C3H 2 times 3 itakuwa ngapi? 6 plus 1 7 kuna. I think you understanding me now. Plus sodium hydroxide plus sodium hydroxide. So these are solid, patia propane ambayo inaandikwa Cn, general formula ilikuwa CnH2n plus 2, so itakuwa C3H8 plus which is gas plus sodium carbonate, which is solid. Sodium carbonate is solid. I think up to now you're understanding. So that's how we prepare alkanes. So sodium alkanoate plus soda lime. That's how we prepare. So tuende chemical properties. So alkanes haina chemical properties mingi. It has only 2 chemical properties. two chemical properties. Number one is known as burning. It's known as burning or combustion. Number one, it has burning. No, it has a combustion. So it burns with which flame? It burns with blue non-sooty flame. It burns with blue flame. Kwa sababu gani? Because it is saturated. It burns with blue flame. So alkanes burns in air to give you carbon dioxide and water. And my student, I want to give you this thing. Remember that any organic compound burns in air to produce two things, carbon dioxide and water. But the air that is reacting depends on whatever the oxide of carbon that we're going to get, be it the carbon 2 or carbon dioxide. What do I mean that? For example, if alkanes or any organic compound is burning with excess or enough air or enough oxygen, it will give you carbon dioxide and water. But if it is burning with limited oxygen or limited air, it will give you carbon dioxide and oxygen and water. Carbon dioxide and water. So that's the one thing that you have to know. Burning hainanga stress mingi. Tuende kwa substitution. So substitution is just involve a hydrogen atom is replaced by halogen atoms. So substitution usually deal with halogens. Either chlorine, either fluorine, either bromine. We are dealing with that two things. Understood? Then condition ni gani? What is the condition for substitution? Ni gani? Substitution is UV light. This is a condition. And sometimes in exam, especially in paper 1, you may be asked, what's the function of UV light? Remember that UV light is ultraviolet ray. So UV light is to break the halogen molecules into its atom. So meaning that if you are dealing with chlorine, you say it's to break the chlorine molecules. If you are dealing with fluorine, it's to break with fluorine molecules. So we are talking about that thing. So then when you are writing this, for example methane reacting with chlorine. Remember that chlorine, the halogens are diatomic molecules. Halogens are diatomic molecules, and diatomic molecules usually exist as twos. Meaning that if I am talking with chlorine, you must write this: bromine, iodine, fluorine, all of them, they exist as two. Meaning that when you are reacting with two hydrogen will be substituted. For example, if I have methane, CH plus chlorine, Cl, it will give me CH moja, H ingine hapa. So ile imebaki sasa ni chlorine mbili, sasa chlorine. So already hapa tumetoa 1 2 H mbili plus it will give you plus hydrogen. It will give you plus hydrogen. It will give me plus hydrogen. Plus hydrogen. So meaning that, what do I mean? Ile kitu sasa hapa mnataka muelewe tu ni moja tu. That is, all halogens exist as twos. So unaandika mbili. And that's all about alkanes. Nimekwambia alkanes ni chemical properties can be burning and substitution. A substitution to not deal with halogens. Condition for substitution, UV light. Function of UV light is to break the halogen molecules into its atom, and that's all. So uses of halogen of alkane, they are used for as fuels. On cracking alkanes, are major source of hydrogen for manufacture of ammonia during HAPA process. Also is manufacture of carbon black, which is a component of printers and inks. Printers of inks. So let's go to alkenes. Remember that this is one of the most important part in organic chemistry. One, alkenes. Remember that if a student know alkene very well, I normally say that that student is okay with organic chemistry. So alkenes, the alkenes zinaishia kwanza in. Also they have a general formula of CnH2n plus H2n, CnH2n. Also they have double bond. They have double bond. Also they have double bond. Also they are unsaturated. Remember that alkanes, we say they are saturated. Alkanes, we say that they are saturated. So alkenes, they occur in from long chain alkanes. So long chain alkane will break, it will give you shorter chain alkanes and hydrogen gas. So in school, how can we prepare? Preparation, because as I already tell you, I will only emphasize on preparation and chemical properties. So preparation. Alkenes may be prepared from dehydration of alkanols. So we dehydrate alkanols. So number one, it can be prepared using dehydration of alkanols. So how can we dehydrate them? During dehydration, we use two things. Either we can use concentrated sulfuric acid. This is a commonly used concentrated sulfuric acid. Also, we can use aluminum oxide. So concentrated sulfuric acid, when you are using concentrated sulfuric acid, for example, if dehydration of alkanols. So for example, if I want to dehydrate any alkanol, for example, if I want to dehydrate ethanol, C2H5OH, if I want to dehydrate using conc acid and hypertianisa, what will I get? I will get 18 C2H4 plus water. Again 18. So remember that during dehydration, during dehydration, we get two things. That is alkene and water. No matter whatever the dehydrating agent that you are going to use, be it conc sulfuric acid or aluminum oxide, no matter whatever that we are using, it will give us alkenes and water. So conc sulfuric acid, it acts as a dehydrating agent, so it will give you alkenes and water. So also sometimes condition, it is very important. Inakuanga from 160 degrees to 180, or any range between them, 160 to 180, or any range between them. So that is how, when you're using concentrated sulfuric acid. So remember that concentrated sulfuric acid dehydrates or removes water from ethanol to form ethene. The gas produced contains traces of carbon dioxide and sulfur dioxide gas as impurities. So it contains two impurities, that is sulfur dioxide and carbon dioxide gas. So it's passed. How can we remove that impurity then? It is passed through potassium or sodium hydroxide solution to remove the impurities. So sometimes that question say sikuona sana ikiwa inatestiwa, but in case itestiwe unafaa ujue because the impurities is two, carbon dioxide and sulfur dioxide, and it is removed through passing sodium hydroxide and potassium hydroxide. So let's go to aluminum oxide then. So it will give us the same thing. It will give us the same thing. Even hapa tukitumia aluminum oxide, it will give us the same. It will give us the same thing. But aluminum oxide, remember that it acts as both the hydrating agent and as well as catalyst. So it dehydrates or remove water from the ethanol to form ethene, and activated aluminum oxide has a very high affinity of water molecules of element of water, thus dehydrate ethanol to form ethene. So that is preparation of ethene. So lab preparation of alkene. How can we prepare in lab? This diagram because here they just do the same thing, you use the same thing. This diagram is very important. This is the diagram, very important indeed. So you have to know if ethanol is highly flammable, concentrated sulfuric acid is highly corrosive on skin contact, common school diameter has maximum of 1, thus cannot be used. Bona he is to make a sometimes school is it breaks because the temperature is very high. So sometimes also some broken porcelain or sand is used. Kosogani is to prevent popping, which may break flask. Also ensure uniform uniform and smooth boiling of the mixture. So let's go to chemical properties of alkane. So this is a very important part. Chemical properties. Okay, number 1, I will start with burning or combustion. So my student, I already told you that anything that burns with any hydrocarbon that burns with air, it will give us carbon dioxide and water, depending on the amount of air that is reacting with it. So it burns with yellow sooty flame. These flames is very important when you are in, especially for Pp2. It burns with yellow sooty flame, and we said for alkanes it burns with blue flame. So that's number 1. So it will give us carbon dioxide and water, burning or combustion. Number 2 is known as addition reaction. So addition reaction of alkene inakuanga number 1 hydrogenation, and hydrohalogenation. That's the 3 addition reactions that you have. So number 1 we have hydrogenation. Number 2 we have halogenation and hydrohalogenation. Remember that halogenation is addition of halogen such as chlorine, bromine, fluorine. That's halogenation. Hydrogenation is addition of hydrogen. Hydrohalogenation is addition of hydrogen halide, the like of HCl, hydrogen bromide. That's something that's contain hydrogen and halogen. It's known as hydrogen halide. So it contains, so ile kitasa tunafaa tujue ni number 1 is condition for hydrogenation. Condition, all of them. Condition and condition gani tunataka? That's the first most important thing that you have. So hydrogenation is addition of hydrogen with alkenes to form corresponding alkanes. So when you add hydrogenation or addition reaction, it will give you alkane. That's automatic. You will get alkane. For example, alkene plus hydrogen, you will get alkane. For example, 18 plus hydrogen, itakupatia ethane. Kwa sababu gani? Because the moment umeona addition reaction kwa organic, the moment umeona addition reaction kwa organic, ile kitu inafaa ikuwe kwa akili yako na inafaa ingie akili yako, it must pop in your mind is bond must break. Bond and a break. That's must. Bond and a break. Bond ikibreak, after that ndo hasa unapatiana hasa kila moja ile space imebaki. For example, if I have 18 ambayo iko hivi, this is 18. May add hydrogen. Nimekwambia nini? Bond must break. This bond must break. Sime break sasa, unabaki sana nini? Unabaki C to C, H, then H. So whatever that will HH. So angalia, nimerudisha tu vile ilikuwa. Alija 1 2 3 4. Hapa ilikuwa 1 2 3 4. So lakini back hapa ilikuwa na double bond, and each carbon between carbon atom must be bonded with 4 bond, because carbon iko na bond inne. So ile imebaki sasa ni hydrogen moja side nyingine na hydrogen nyingine hapa, and that's all. So carbon moja ni 1 2 3 4, hii ni 1 2 3 4, imeisha. So hii sasa ilikuwa 18, hii ilikuwa hydrogen. So ukapata aje sasa? Ukapata ethane. So and I normally advise my student, as much as you can in organic chemistry, you use open structure. This is the easiest way to understand organic chemistry. So condition for hydrogenation. Condition number 1 is temperature of 150 to 250 Celsius. Also tunahitaji catalyst. Name the catalyst that's used. Very common question indeed. Catalyst is either palladium or nickel catalyst, or nickel, mostly nickel. Kwanza unaona tu kitu imeandikwa hivi, tena unaona tu ni imeandikwa kwa most of the exams. Unaona tu ni mahali imeandikwa, so inaonyesha ni nickel catalyst. So pressure also, ile kitu tunahitaji ni pressure of 200 to 250 degrees Celsius. Also ile kitu tunahitaji ni reagent, na reagent ni hydrogen, that's automatic. So that is hydrogenation. Number 1 nimekwambia hydrogenation temperature of 150 to 50, catalyst of palladium and nickel, very important, and pressure of 200 to 250. So let's go to, so when hydrogen gas is passed through a liquid, vegetable and animal fat, it at about 180 degrees Celsius in the presence of nickel catalyst, solid fat is formed. So hydrogenation is thus used to harden oil to solid fat, especially in manufacture of margarine. So hii swali sana inaulizwa sana. So uses of hydrogenation, wanakupatia process, wanakuambia name uses. Use ni gani? Is used to harden oil into fats, used to harden. So halogenation ni you just react with halogens, the like of fluorine, chlorine, bromine, iodine, and it will give you haloalkane. It will give you haloalkane. So let me do one. Let me do one example. For example, nikichukua propene. So propene react plus chlorine. React chlorine because chlorine its atomic molecules mbili anapatia jaza. Wewe sasa usishulike, unaandika tu vile iko tu, unaona vile iko unaandika na unatoa tu hii bond. Tulisema bond must break, so inakuwa aje 1 H hapa ilikuwa H, hapa ilikuwa H C H H C, hapa ilikuwa H C H H. So ona sasa automatically there's two space itakuwa free. Hii ni space moja na space nyingine. Sasa hiyo space nini itaingia chlorine ndio itaingia sasa. Chlorine ndio itaingia. Kama unaweza sema tu hapa H hapa iko chlorine. So itakuwa sasa nini? 1,2 dichloro. Itakuwa 1,2 dichloro. Hapa tukiweka chlorine H. Itakuwa chlorine 1,2 dichloro propane. 1,2 dichloro propane. So niende kwa hydrogen halide or hydrohalogenation. Most of the student common mistakes, first of all, I have to say the common mistake that student most of them make. Most of the students confuse addition reaction involving halogen and hydrohalide. To differentiate the two, note that in addition of halogen, 2 halogen atoms are added to the alkanes. But in addition involving hydrogen halide or hydrohalide, only 1 atom was added. What do I mean that? I mean when you are dealing with halogenation. When you are dealing with halogenation, 2 halogen atoms added. Kwa sababu gani? Because they exist as twos. For example, kama ni chlorine, una add chlorine mbili. Lakini hydrogen halide, kama for example kama ni HCl, una add 2 hydrogen moja na chlorine moja. And that's all. This is kitu mbili already. Inakuwa tofauti. So that is hydrogen halide. So reaction with bromine water, that's number 3 is bromine water. Bromine water is formed due to halogen involved in distilled water. Bromine water has formula of HOBr, halogen bromide. So reaction with bromine water. Reaction with bromine water. Hapa pia kuna mistake hasa. Remember that hapa kuna mistake kubwa sana. Remember that there is a difference between bromine gas or bromine vapor, which is brown, and bromine water, which is yellow. This thing even teachers will not tell you. I will tell you this thing. Also, this thing teachers will not tell you. What I will tell you is there's a difference between bromine water and bromine vapor. Remember that bromine gas is brown and bromine vapor water is yellow. So what I will tell you is bromine gas or vapor is brown. It's brown. Also the bromine water, bromine water is yellow. Bromine water is yellow. Differentiate that, please and please and please. So during reaction between alkenes and hydrogen bromide, not hydrogen bromide, bromine water, the bromine water turns from yellow to colorless. And this is practical in Pp2. We use bromine water, which is yellow, not the bromine, the brown one, or red brown as color of bromine water is penalized in. So hii sasa kwa examination when marking is very important. It's very important. It's very important. Remember that bromine water is yellow, while bromine vapor or gas is brown. So there are two different things. So bromine water reacts with alkene to form bromoalkanol. So bromine water react with alkene to give you bromoalkanol. For example, what do I mean? For example, 18. For example, niko na 18 H H gonna brown plus bromine water HOBr. I add, so it will give us, wewe unaandika tu vile iko, so that's why nakwambia this is 18, this is bromine water. So that's why nakwambia use open structure as possible. So nakupatia, unaandika tu vile iko tu, unakuwa H kwa to C C OH, then hapo unaweka bromine ama bromine uweke hapa. Si hizi space mbili, hizi mbili ndio itabaki tu. So hizi mbili either hapa unaweka bromine ama hapo uweke OH, it's up to you. So unaweka ile mali. So this is the kwanza, ukiweka hapa itakuwa, ukianza hapa itakuwa 2 promo ethanol. So itakuwa 2 bromo ethanol. So that is reaction with bromine water. And nimekuambia difference between bromine water and bromine vapor tafadhali. So niende kwa oxidation. So oxidation, alkene is oxidized to alkanol with due to double functional group. So oxidation hasa oxidizing agent tunatumia ni mbili tu. Hapa ni si dry sana. Oxidation tunatumia ni potassium permanganate. Also ile kitu kingine tunatumia ni potassium dichromate, acidified potassium dichromate. So ethene is oxidized to ethene than 1,2-diol by acidified potassium permanganate solution or acidified potassium dichromate. So it will give you one thing. And also hapa ile kitu iko muhimu sana ni the color changes. What is very important here is the color changes. So we say that bromine water, when you're talking bromine water, it will turn from yellow to colorless. So also potassium permanganate, there's a color change for potassium permanganate and potassium dichromate, which is very important. So acidified orange potassium dichromate changes from turns to orange to green, natoka from orange to green, and also potassium permanganate natoka from purple to colorless. Let me write this for you. So potassium dichromate kuna mbili inatoka from orange to green, from orange to green. Also potassium permanganate inatoka from purple, to colorless. As hapa pia nataka niwaambie kitu iko important sana, even most of the teachers they confuse. So that is, remember that reagent must be acidified. That's rule number 1. Another thing is acidified potassium dichromate does not test for unsaturation. Please and please, this one does not test unsaturation. This one does not test unsaturation, please. This one does not test unsaturation. So acidified potassium dichromate only tests ROH. It only tests ROH. This thing, get it clear, please. Potassium dichromate does not test for unsaturation. It only tests for ROH. But acidified potassium permanganate, these are universal. So this tests both. Potassium permanganate, it tests both. Both inamaanisha nini? It tests both unsaturation and also ROH. It tests. So the next thing is hydrolysis. Next is hydrolysis. Hydrolysis means that reacting a compound with water. So let me go to hydrolysis. So hydrolysis inamaanisha nini? Is a compound reacting a compound with water. So for example, alkenes react with concentrated sulfuric acid to form alkyl hydrogen sulfate, and alkyl hydrogen sulfate react with water and warm itatupatia nini alkanols. So hii ina taking in two steps. It take place in two steps. Number 1 tunafanya aje? Tunafanya alkene ndio tuna add concentrated sulfuric acid. Yanipatia sa nini? Alkyl. Yanipatia alkyl hydrogen sulfate. So this alkyl hydrogen sulfate sasa ndio na add water plus water. Yanipatia plus water. This plus water sana yanipatia sa nini? Yanipatia alkanol. Yanipatia alkanol. So nimekwambia alkene, I will add with concentrated sulfuric acid. Yanipatia nini? Alkyl hydrogen sulfate. And this alkyl hydrogen sulfate ndio na add water, then yanipatia alkanol. Yanipatia nini? Alkanol. And that's all. So for example, kama unataka equation, for example this is H2 plus sulfuric acid, anipatia sa nini? Anipatia this is ethyl hydrogen sulfate, CH2 or SO3H. And also this, if we add water plus water, anipatia ethanol plus sulfuric acid. So anipatia ethanol, this is C2H5OH plus sulfuric acid. Dilute sulfuric acid, anipatia dilute. So that's why sometimes unaona ukienda kuangalia chemistry form 3, hizi questions ziko nyuma. Ukienda kuangalia the flowcharts ambaye iko huko. So I think ni mbili that past paper. So one of it ndio ina test hii. So wamekuwekea hapa, for example sijui kama hapa ni x, then wanakuandikia x plus H2SO4. So ukiona sasa hii H2SO4 automatically this x itakuwa nini? Itakuwa alkanols depending of the whatever the alkene is used. That's known as hydration. Let's go to not hydration, hydrolysis. Let's go to hydration. Ethene react to the steam to form ethanol. So ethene usually react to the steam, and this is the equation. React with the steam to form ethanol. So the condition for hydration is are pressure of 60 atmosphere and a temperature of 300 degrees Celsius, and also phosphoric acid as a catalyst. Very important. So let's go to polymerization. Polymerization inaitwanga self addition reaction. Self addition imekwambia addition, self iko addition yani nyuma. So meaning that nimekwambia addition reaction, the moment umeona addition reaction, ile kitu itaingia kile yako nini? The bond ita break. Yes, very good. So inakuwa hivi sasa. For example, if I have 18, if I have 18 imeta self, meaning that una self yani una add one atom of the same nature. So meaning that one hydrocarbon of the same nature, I mean. So this is 18 plus 18 ingine sasa. 18 ingine. So wewe usisumbue, sini hizi ni moja, take it to chukua tu moja. That is C. Chukua sio. So bond na break. Weka hii hapo sasa. So hapa ni H. So hapa imebaki sio. So sema hivi. So itakuwa hivi, this hapa ni itakuwa sasa nini? Itakuwa N. So remember that the concept of polymerization, imagine watu wengi wameshikana mkono. Polymerization hivyo, watu wengi wameshikana mkono. For example, mtu mmoja ashike mwingine mkono, mwingine ashike mkono, So at the end of the chain tapata mtu ambaye ako nyuma, tuseme mtu ameshikana hapa, mwingine ameshikana hapa. So at the end of the chain tunapata mkono ya mtu mmoja iko hanging, hakuna mtu ameshika because chain imeisha. Then mtu wa kwanza side hii mkono yake pia iko hanging, that's why tunaweka hivi. So tunasema poly because inamaanisha nini? Ni mingi sana, mingi. So that's why tunaweka hivi. So that's the concept of that's how students should understand concept of polymerization. So test for unsaturation tuliongelea, tulisema unsaturated compound is a compound that double or triple bond inaitwa unsaturated. So we test using bromine water and acidified potassium permanganate because potassium dichromate only test for ROH. So use of alkenes, manufacture of plastics, hydrolysis of ethene is used to industrial manufacture of ethanol. Ethene is used in ripening of fruits, manufacture of detergent. Hiyo utasomea. So tuende kwa alkynes. So alkynes hatutaingilia sana. Alkynes yeye haina stress. So it has triple bond. Triple bond. So also it has a general formula of CnH2n minus 2. Also it is unsaturated because unsaturated ni ile iko na double and triple bond. So how tuende kwa preparation we usually prepare ethyne only in alkynes. So meaning that itakuwa calcium carbide reaction between calcium carbide plus water. Reaction between calcium carbide and water, which will give us calcium hydroxide, which is aqueous, and ethyne C2H2, which is a gas. It's a gas. To keep balance, remember that you have to balance equation. This is chemistry. This is solid and liquid. You must balance solid, liquid. So this is we usually tunatumia tu calcium carbide and water. And in all exam unaona tu ethyne kama kuna test ya preparation ni calcium carbide ambaye ni ethyne. So that is chemical properties. Chemical properties by the way, kama unajua ya alkenes, unajua ya alkynes, hiyo ina stress. Remember that kama ni addition, kama bond ina break, inamaanisha bond yote i break. For example, alkyne iko na triple bond, so moja ina break, unabaki na bond mbili. Alkenes ni double bond, iko na double bond, moja kibreak unabaki na ngapi? Moja. So alkenes hainanga addition reaction, iko na substitution reaction. Tuna substitute. So tuna substitute. So I want you to look at this summary. I will give you summary at the end, which covers all of the flowchart, that covers all of the things that we covered, all of that. So as a student, you have to screenshot. Just screenshot it. You have to screenshot and then use it. So this is a screenshot. Just a screenshot. And also if you're using YouTube, you just pause. And so this is easy meswali reaction 2, reaction 1, reaction 5, chloro. This is chloroethane. This is chloroethane here. This is chloroethane. This is chloroethane. If you're not seeing well, chloroethane, solid T, soda lime, hivyo. Then summary table gani? This is summary table. This is the answers, conditions na ile kitu. Lakini first of all, before you came to these answers, please, first of all, you have to know if you understand the concept very well by examining yourself. So lazima uone kama umeelewa. So this is the next one is this. The next one is this. write the equation. Step 3 ni hivyo inaandikwa, then name the substance ni hiyo, substance ni hiyo, substance ni hiyo, substance ni hiyo. So that's all about our lesson. That's all about our lesson. Remember to subscribe the channel if you're not, and if you have subscribed, thank you for that. Remember that this is your teacher Mohammed Khalif, founder of MKLI Tuition, where science meets success. Usually learn smart, score high. From chemistry to physics, MKLI Tuition makes turning struggle into S. Your success history start here. Remember, your success history start here. So if you want to private tuition, also we usually offer, and my number is on description below. Thank you.